Hi everyone, it's Ellie from the Curious Geographer, and today, very exciting, we are joined by Professor Christopher Jackson, and we're going to be talking about many things to do with volcanoes, Chris's research, and kind of filming around volcanic landscapes as well. So lots to talk about today. Professor Chris Jackson is trained as a geologist. He did his BSc at the University of Manchester and stayed there to complete his PhD. He's actually joining us from Norway, which is super exciting. So we'll get to hear a lot about what he's up to and his current research. If you haven't already, have a look at the QR code on things which are coming up. There's a few other things on kind of A-level geography as well coming up after half term, and to check out the other live events. So I'm going to pass over to Professor Jackson. If you could just introduce yourself and tell us a bit about you, that would be fantastic.
Hi, yes. Hi, everybody. I'm Chris Jackson. I'm a geoscientist or a geologist, and I'm based at Imperial College in London, although I'm physically at the moment in Western Norway in a city called Bergen. So thank you, Ellie, so much for inviting me to come on to talk about geology and talking about geology and showing people geology, because it's one of my favourite things.
You completed your PhD in geology, but your research includes, as you said, your kind of geoscience. You cover a range of different kind of aspects of research in tectonics, particularly volcanoes. But what exactly does a geologist do? Can you tell us a bit about that?
Yeah. So geologists do lots and lots and lots of different things. So I don't know. When you ask somebody what a geologist is, you probably think of people with like waterproof clothes on in the rain, looking at rocks and hitting them with hammers and that sort of thing. But geologists do a bewildering array of things. So we are involved in both research and teaching, and applied geoscience as well. So what do I mean by that? So if we think about applied geosciences, this is how we can use our understanding of the structure and evolution of the Earth to find, for example, water resources. So if we want to find clean and secure water sources, they're typically stored in the rocks beneath our feet, or in some places they're stored in the rocks beneath our feet. So we need to understand how the rock layers are organized. We need to understand what the structure of those rock layers are to allow us to get them out. Same with hydrocarbons, oil and gas. Increasingly, geosciences in an applied sense is being used to look for storage sites for carbon dioxide, so kind of waste from our energy production, and also nuclear fuels as well. So there's lots and lots of things geoscientists are doing to kind of help society. And then, we help society as well in an academic sense by teaching people about geosciences. So some academic geoscientists teach people all about rocks. So, be that structural geology, so being in the field, be that geophysics, which is using physics to understand what's inside the earth, or whether it's, geochemistry. So we take rock samples or water samples and we analyze them to work out things like the chemistry of the rocks or the fluids, and when they formed and where they formed as well. So we basically are the best people in the world. We can do everything. We're very, very useful.
I would definitely agree, very, very useful. And we're going to talk a little bit about also when you have been filming and working with different communities as well, looking at volcanic areas. I didn't mention at the beginning, but if anybody also does have questions as we go through, just please write them in the comments and we'll try and get to them as well. So questions are definitely welcome, please. So kind of just an interesting question from me, what I would quite like to know is, what do you think the most dangerous volcano on Earth is?
Now, this is a really contentious question because it depends how you're defining that danger. If you're defining it as how many people could be killed by it, that's kind of because, and I think when most people ask danger, they think of like lava flowing down the sides and like big like explosions. But there are ways in which volcanoes can sort of endanger lives over much longer periods of time by perturbing the weather patterns, and you can actually cause crops to fail years after, or a few years after a volcanic eruption, and that could happen to a place on the other side of the world to where the volcano erupted. So it's a really, really complicated question to answer, and for those reasons. Also, when a volcano erupts is really important. If it's during the day or it's at night, people will either be out of their houses or in their houses or nearer to the volcano or further away. Having said that, there are some volcanoes or people who make claims on the behalf of the volcano, because remember, volcanoes don't make claims themselves. There's people who claim, things like Vesuvius in Italy is one of the most dangerous because it's capable of producing a range of different eruption styles with lava, with big pyroclastic flows. These are the sorts of things that kind of wiped out Herculaneum and the cities on the south side there. So and that and if you look at the evidence around somewhere like Vesuvius, you can see that if the same eruptions were to happen again, then they'd be devastating. Now you've got Naples, this huge city sitting on the side of it. Nyiragongo, where I went to in the Democratic Republic of Congo, of course, that's capable of these very long run-out lava flows. So lava flows that go a long way and can actually encroach onto the city, which has over 1 million people. So there is a list called the Decade. I think it still exists, called the Decade Volcanoes. It's worth looking at if you Google that, and it has, I think, the world's kind of top 10 most dangerous volcanoes on it. And they're assigned as dangerous because they can pose a threat to tens to hundreds of thousands of people in multiple ways, and that means both ash-rich eruptions, lava-rich eruptions, these big pyroclastic flows. They have to have quite volatile and extreme behaviours and pose a threat to a lot of people. So I don't know if that's the answer you wanted, because normally somebody wants it to be like the kind of top 40 charts, like the music things on Sunday.
That was great. And then also I like the idea of looking up the decade list as well. I'm definitely going to use that with students as well to see kind of what is classified as like dangerous. But I like your answer also, very geographical. It depends. Yeah,
it's pretty cool because it makes you, if you look at where those volcanoes are, like one really important thing is that they're often near populated areas, right? So there's clearly an encroachment of us as humans onto those volcanic landscapes, which means that we're increasingly at risk. The volcanoes haven't been moving around trying to become more dangerous. They've always been there.
It's also interesting that you talk about Vesuvius as well. So I went there not this summer, last summer, and it's quite, because the city is literally like in the shadow of the volcano, and you can always see it kind of from the coastal areas. But actually thinking that it, like, what if, because it seems at the moment so kind of calm, and there's lots of tourism that goes there and tours, and so yeah, that's just quite interesting. Kind of linking potentially to our next question, talking about ancient volcanoes, which is what some of your research is on. Where are kind of all the ancient volcanoes on Earth, and what does it mean by they're kind of long extinct?
Yeah, so the kind of extinct, or the extinct volcanoes on Earth are everywhere. The ones that I study, I think, are the coolest ones because they are buried beneath the sea. So these are volcanoes that were forming either at land or in the oceans of the past, and they're now buried beneath sedimentary rocks deep beneath the seafloor. By deep, I mean between a few hundred meters and a few kilometers. And we use this seismic reflection imaging, this geophysical technique, to image these ancient volcanoes which are offshore. And those ones are beautiful. They look like volcanoes, and they've got a big pointy top, and we can do loads of cool bits of science with them. All other ancient volcanoes are on land, and they are now deeply eroded. So these are things like, you think about Arthur's Seat in Edinburgh, and these are old. These are, I think, Carboniferous age, so 300 or so million-year-old volcanoes, and they don't look like volcanoes really, right? They don't have a triangular shape, and that's because what you're now seeing is almost the roots of those volcanoes and the innards, the guts of those volcanoes, because they've been long extinct. We've had various types of erosional processes wearing them down, and so we just get snippets. We get little windows into what those volcanoes look like. The Lake District, North Wales, there's evidence of there's volcanic products from hundreds of millions of years ago in North Wales and the Lake District, but there's not seemingly any volcanoes. But the fingerprint of that volcanic activity is there. Even Derbyshire, where I'm from, there's evidence of Carboniferous volcanism there. But we just get these little postage stamp kind of bits of evidence on for many of the onshore volcanoes. But having said that, some modern volcanoes which have pointy tops and the triangular shapes, they are extinct, we think, but we never really know sometimes.
So, as a geologist looking at, say, Edinburgh and St Arthur's Seat, we're talking about those kind of ancient, have areas that I quite like to describe almost like the roots of volcanoes. Is that from looking at the geology of the ground that you see patterns? Is that how you kind of work it out?
Yeah, so what you'd be doing is looking at the types of rocks that you find in those areas. So igneous rocks are the classic type, and you might get some sediment. So igneous rocks are kind of formed from the cooling of magma beneath the earth, or lava if it is extruded onto the earth. So you get these igneous rocks. And you may also get sedimentary rocks, so things like ashes, which are formed by these kind of big pyroclastic flows, and this is kind of material or magma which is kind of expelled from inside the volcano and cools as it's traveling up into the atmosphere or along the sides of the volcano. So you'll get sedimentary rocks and igneous rocks, and even metamorphic rocks sometimes, because as the magma is in contact with the sedimentary rocks, it bakes it, it heats it up and slightly metamorphoses it. So you try and use all of those patterns and those types of rocks to kind of reconstruct the volcano. The other really cool thing you can do is look at kind of where the lava rocks are and where the pyroclastic rocks are, the kind of sedimentary rocks, how thick they are. If they get thinner progressively away from a central point, that central point might be the kind of the kind of center cone of the volcano, and you're kind of seeing the last vestiges of the things that were thrown out of it hundreds of millions of years ago.
So yeah, you kind of answered my question. I was going to say, when we're thinking about ancient volcanoes, how old is ancient, considering
billions, loads, super old, yeah.
Billions, okay. Because when we're thinking about, if I was to say to my students that, yeah, we've got tectonic landscapes kind of near Edinburgh, they'd say, well, we're nowhere near a plate margin. So this is from millions and billions of years.
Yeah.
Okay.
No, exactly, and it's important to remember that the arrangement of the Earth's tectonic plates now is different to the arrangement of the Earth's tectonic plates in the past, and so and the kind of there's that thing, that the Earth is very dynamic and is moving around, and it's not just at plate margins that you get volcanism. So you get volcanism where you're stretching the Earth's crust in rift valleys. Mid-Atlantic ridge, you get volcanoes where you have subduction, so a plate goes down and melts, and you expel some of that melt upwards. But you also can get things like hotspot volcanoes, or these volcanoes which are intraplate, we call them, and things like Hawaii. So there's a reason why deep beneath the Earth is melting. So there's different places that these volcanoes can form in.
Brilliant. And we've got a few questions coming in. So if anybody else does have questions, if you just write them down, some of them I think might be covered as we do through the next couple of questions. But kind of we've kind of really started talking about kind of ancient volcanoes. And do you mind telling us a little bit about what your current research, what you're currently researching?
Yeah, so I'm doing lots and lots of different things with lots of different rocks. But one of the kind of very exciting things I'm working on at the moment is these ancient volcanoes and the roots of these ancient volcanoes. So, like I said earlier on, you can go in the field, you can reconstruct these ancient volcanic processes and the structure of these volcanoes by going out into these ancient landscapes. But another thing you can do is use seismic reflection data. So this is where you tow in the marine survey, you tow a boat, you have a big explosion, it sends some acoustic energy or some sound waves down into the Earth. They bounce back off the rock layers, and you record them with these things called geophones or hydrophones. And from that, you essentially build up an X-ray of the Earth, or a CT scan. So it's like, imagine your body, scanning your body and seeing the bones and not looking at the soft tissue. That's essentially what we're trying to do when we're using these geophysical techniques called seismic reflection data, or seismic reflection imaging. And so from that, you'll see these beautiful images that hopefully you've got an image of on the screen now of an ancient volcano. And you can see it's got this triangular shape. You can see underneath it, there's some very bright colors, and these are things which we call sills. So these are igneous sills, and these are the kind of, call them magma conduits, right? The magma has to rise from deep in the Earth, and one way it rises is via these things called sills and these other things called dikes. and then they go up and they can feed these volcanic centers or these volcanoes. So this image you're looking at here is from offshore southern Australia, actually. So it's a long way away, and yet the cool thing is we can get those data kind of sent to us here in Norway or in London and actually interpret these volcanoes. And also that volcano you're looking at there is 42 million years old, so it's Eocene age, so it's older than me. So yeah, you're looking at a very old volcano from very far away, and we can do lots of things. And one thing you can do with this volcano, you can see on the screen, is you can see inside it. And although it's extinct, you can really start to kind of pick apart what these ancient volcanoes look like. Because if you can do that, that might inform us about what modern hazardous active volcanoes look like inside and how they may behave in the future.
That's really interesting. So kind of almost, yeah, kind of ancient volcanoes is informing like future research as well. How often would you go out and actually physically be there to collect data? As you said, it can kind of get sent over to you where you are. Do you ever go to like on the boats when they're collecting data?
No, so there's two main types of data acquisition that occur for this sort of seismic reflection images like you just saw. There's academic cruises, so this is where academics kind of get some boat time and go out, relatively small scale operations they can be, and go out and collect a bit of data. But sometimes that data is quite small and quite focused. The kind of better data sets, in my view, or the ones we've used mainly, are ones collected by the oil and gas industry. So they go out with like huge boats and loads of people, and they collect this data over enormous areas because they've got like loads and loads of money. And because volcanoes are big and these volcanic landscapes are really big, we need that big data. We need that data to cover hundreds of kilometers to thousands of kilometers squared. So I've never been on those cruises because they're primarily for industrial purposes. So I can just sit around at home waiting for somebody to bring data to my doorstep and then try and do the best with it when it gets to me, really.
And so like are they quite happy? Do they just give you the data as well? Is there like agreements with like research groups to get data from?
Yeah. So there's a confidentiality agreement because those data are worth millions and millions and millions and millions of pounds. And because it's valuable for prospecting for energy sources or for storage of carbon dioxide, let's say. So they're very, very valuable, but they will give them to academics for academic research. And they're kind of not that interested in volcanoes, let's say, but we're supremely interested in volcanoes, so we can kind of get access to those data, and it's very handy.
And you're over in Norway at the moment. Is that you're continuing, obviously, the kind of sea ancient volcanoes as well? But is there a certain reason that you're out there out in Norway in particular?
Yes, I'm doing bits of research on, again, lots of things like submarine landslides. I'm doing some work on a thing called salt tectonics, and salt is this stuff you put on your chips, of course, but it's also this weird rock type that kind of flows over tens of millions of years and does all these crazy things. So I'm also working with that. But we're also doing some work on data from offshore Australia, looking at ancient volcanoes there. So these volcanoes are about 142 million years old. And these volcanoes and all these sills and dikes are buried about 3 kilometers beneath the seabed offshore Australia. So me and some colleagues here are making maps of these and trying to see how big they are and trying to understand how the magma flowed inside them and trying to work out, how many sills you need to get magma all the way from deep in the Earth's crust all the way up to the ancient seabed and kind of how the mechanics of that work. So it's a very hard problem, it turns out. But lots about science is quite hard, but it's good fun.
Yeah, it sounds good, like quite technical as well with like mapping it. I can imagine.
Yeah, it's really good fun, and it's I don't know. You get to see something which is 140 million years old, which is on the other side of the planet. I mean, how cool is that?
That's really cool. Going on to some of your, where some of our guests may have seen you from, Expedition Volcano, which was on the BBC, I don't know how many years ago, but I showed it actually. I was saying to my students today when we were studying a bit about volcano landscapes in Africa. And you have visited some I know we said we couldn't say which was like the most dangerous volcano earlier, but some of the most dangerous volcanoes in the world, and you did mention this one as well. What were your aims when you were out there with the BBC filming, and what was it like actually filming around a volcano?
Yeah, so it's kind of interesting. Why were we there? We were there to make a TV show, and that's one thing I think you should always realise about science telly. Normally, they're there to make a telly show. There's a bunch of scientists who would love to do some science or are doing science and have been doing science for many, many years before the TV crew turned up and started pointing cameras everywhere. So, there is a tension, an interesting tension there where you're trying to make a TV show and bring to life some of the important bits of science being done. But equally, there's a bunch of scientists there trying to do some science which has massive societal relevance for the people living not just around Neogongo, in that case, in Goma and the surrounding areas, but also, volcanoes elsewhere on the planet. So there is that challenge of trying to achieve the goals of both of those groups of people, the TV production company and also the scientists. So that's kind of what we were doing. So, there were some scientists out there who were trying to test some new technology, right? So they were trying to use infrasound for understanding the acoustics of volcanoes. There were some scientists out there trying to collect gases to see if some of the gas concentrations and types, kind of whether they could tell you whether a volcano was becoming increasingly active and might be moving towards an eruption. There were some scientists out there who've been working there for many years and were there simply to replace bits of equipment and put new batteries on stuff to keep the monitoring going. So there's all of these moving parts when you're trying to make that show, and that kind of relates to the second part of your question, is what was it like being out there? So you're trying to do some like hard science, or I wasn't. I was there mainly to kind of talk to the scientists really about what they were doing. And there's all the stresses of doing that, but then there's all the stresses of trying to make the TV show in this landscape, which is demonstrably dangerous in an environment. Just the kind of natural environment is kind of very intense. It's hot, it's very humid. There's rock falls, there's rain, it's cold, there's lava bubbling everywhere. There's lots of kind of things there, and there's also a tension which is brought about by the humanitarian conflicts that have arisen and are ongoing in that region. So can you imagine? You've got all of those things at play. So it is kind of stressful. It's amazingly beautiful, and you feel it's really important. But you are very aware of all of those things that are going on and the related challenges.
I'm just going to ask this question, which one of our questions. We've got a few other ones coming up, if that's okay with you, Chris. But linking to this place, I don't know maybe whether you were you had a different feeling because you were filming there. But one question from Ardil saying, what do you think is the most volcanically interesting place in the world, like in your personal view?
Oh no, I don't know. Volcanically interesting place in the world. This is one of those questions where there's probably a load of volcanologists out there who like want to choose their favourite volcano, and you get very cross if I don't. I don't know about interesting, because I think they're all interesting for various reasons. I would say the most kind of spectacular one I've probably been to, and I've not been to like every volcano on Earth, I've been to, quite a few active ones now, but I think Stromboli's amazing in the Aeolian Islands, so north of Sicily, because you kind of go out and there's these islands and they look like islands, but they also look like volcanoes. They are just like these triangular conical shapes rising out of the ocean. And Stromboli's spectacular because it erupts every 7 to 16 minutes or so. There's these big Strombolian eruptions. So it's boom, boom, boom. At night, during the day, it's always going off. So it kind of feels like you're on a volcano, steep slopes rising out the ocean, lava coming out the top. There's a Sciaro del Fuoco. I probably said that wrong in my terrible Italian. But on one side of the volcano, there's a big volcanic landslide. So because these volcanoes are building up and the slopes get quite steep and they're layered slopes, they can become quite unstable. So sometimes they fail. And these landslides go down into the ocean, into the water, and can cause tsunami. So they can cause these, I won't say tidal waves, quote unquote, but tsunami. So this is like a pocket-sized island. I mean, you can get across this thing in less than a day, probably. And there's lots of interesting, exciting science being done there, both in terms of the chemistry of the lavas and the gases, the stability of the slopes. The record of ancient landslides is in the bathymetry, so the seabed maps around there are just gorgeous. You see these huge blocks that have fallen off Stromboli. So I just remember going there when I was learning about it to do the filming. I sort of knew about it, right? And I'd learned a bit about Strombolian eruptions when I was like little. But I just thought it was the most amazing place. And it's not, it's not highly populated, so maybe it's not the most important from a geohazards point of view, but it is just a gorgeous piece of rock.
And that kind of links, I don't know if this links to another question from David saying, it seems like you've travelled loads, which is really exciting. And for students also actually seeing a geologist kind of really go into the field and exploring different places. What has been the highlight of your career so far, do you think?
Just in terms of general geology related travel, I guess. Goodness.
Or it could be anything. It could be that if you've been recognised for something, because we're going to talk about careers in a sec. But
yeah, it's a very good question. I mean, I remember when I went to Mount St. Helens in the Pacific Northwest, and I'd sort of, I kind of remembered the eruption from sort of like when I was a kid a little bit. And then, it's like a famous eruption at Mount St. Helens. And I remember like the morning waking up in Portland, and like, it was kind of, and this was about 4 or 5 years ago, and I felt like it was the most excited I'd probably ever been ever since I was a child waking up for Christmas Day, because I knew we were going to drive to go and see this thing, which kind of was almost like a pilgrimage for geoscientists to go and see this volcano. And I remember kind of driving, you drive through, I think, the Columbia River basalts. There's like this big gorge you drive through, and there's all these beautiful lavas, and then you kind of go up and you get these little like views of Mount St. Helens, and you just forget how big it is and how big the scar is in the side of this volcano from when it erupted. And I think, like, I don't know, is that visibly the most beautiful place I've ever been to? But maybe not. But just when it's allied with the kind of importance, if you will, or the kind of excitement I had about going there. And you go to Johnson Ridge, where the Johnson Observatory, where, the USGS geoscientist who was kind of working there, is named after him. And it's just amazing to hear the stories about the people who lived around there. And there's stories like that, of course, in lots and lots of volcanic terrains around the world. But that was pretty special, I think, for me.
That's really cool. Yeah. We've got a bit of a level question. Say, I'm just gonna read it out. So, an A-level geographers study mitigation techniques for the volcanoes, and they, which like lower income countries are surprisingly well prepared and able to respond. Which countries worry you about potentially being unprepared?
I don't know. I wouldn't want to point the finger at any particular one country, but I think there's lots of countries in developing nations, let's say, where there are numerous issues to do with not only the monitoring, but also, so it depends what you mean by mitigation, really. I mean, monitoring is one thing. Whether you can mitigate a volcanic eruption, I guess you can by being prepared and actually having an evacuation plan in place, which the local populace are willing and able to respond to if they leave their kind of homes, and you can then house them somewhere else and keep them warm and dry and fed. But I think there's lots of countries, or quite a few countries, where there are issues. Nyiragongo was in the news last week, I think it was. There's concerns about the level of funding going into the GVO, the Goma Volcanic Observatory there. Because if you can't monitor it, it doesn't matter sort of what mitigation and evacuation plan you've got in place. You won't have enough time to respond if you can't issue a warning with sufficient kind of time for people to respond. The other thing is something, we explored in Expedition Volcano. It's, the trust of the people to the, in the officials who might be advising them. So if somebody keeps saying, leave your home, leave your home, leave your home, and these alarms are going off, and you need to leave what limited possessions you have in a house that could get looted or something, you might be reluctant to leave. So I think there's lots of human issues which act upon those posed by the geohazard itself and can compound it in some ways. Yeah.
How often are local people do they actually work with, say, scientists who come and start to like monitor the volcanoes? Is that does that happen often, where you've got kind of local people trained up?
Yeah, I guess there are some kind of, I don't know if you call it citizen science, but there's certainly some places where observatories partner with local communities to keep them informed about the hazards. And there's places where people go and instrument volcanoes, and they need the local communities to kind of swap out batteries, or to, can we put this thing in the back garden of yours, because we're going to, so there is a collaboration of sorts going on there. And that's probably the best type of science, really, is where you engage the local population. I think it probably does two things. It means you get the right data in the right places, because you get access to all of those areas. But more importantly, you build trust with the local communities, and you engage them in the science. So there's a science communication and engagement aspect to it as well. And that increased level of trust perhaps would then manifest in more trust when there's advice being given, or policies are being sent down from up high to these local communities. They're more likely to respond.
And another question before we kind of hear a bit about how you got to where you are, from Sandra saying, could you considering you study kind of ancient volcanoes, can you share any connections between climate change and volcanoes? I'm not sure if that's where your interest lies at all, but
not historically, no. But there is a clear link. Some big volcanic eruptions send up these aerosols and things that go into the atmosphere, and they can change weather patterns. So they can change weather patterns over relatively small time scales. Sorry, my smallest daughter's just appeared in the room. Ignore her. Yeah, weather patterns can change as well. But then also, over longer term kind of climatic perturbations as well. So whether you get like sustained lowering of temperatures because of volcanic eruptions, and that certainly happens for some of things like Pinatubo, some of the real big bangs, where they're very kind of ashy eruptions. That does happen. So yeah, and we're going to be talking a bit about that, I think, in the Christmas lectures, about the link between volcanism and climate change, because it's obviously a very exciting thing.
And just so say hi.
There's a small child behind me in the cup.
Hello.
What's up, Doc? It's all right.
So people can see, where would those Christmas lectures be?
So the Christmas lectures, 3:00 Boxing Day is my lecture on BBC 4, I think. And then Helen Chertsky will be on the 27th of December, and then Tara Shine will be on the 28th. So tune in and watch them. Please.
Yeah, I'll give you time to plug anything else at the end as well. Thinking about careers, I really like, because we have a lot of A-level students watching as well, who are thinking about going to university and kind of thinking about careers. So we are going to ask all guests this. So kind of, how did you get to where you are today? And do you have any advice for students kind of taking that next step beyond school?
So I'm very old, so where I got today is a very, very long story. So that's a separate YouTube broadcast, probably. But just to pick out the important bits, maybe. So I grew up in Derbyshire, so I was always spending, I'm from Derby. We spend a lot of time caravanning and camping. My parents used to love caravanning and camping in the Peak District, so I was always kind of outside in the kind of outdoors. And having said that, I was never particularly interested in the rocks that were around me, but I think I had an affinity with wanting to do something where there was at least an option to go outdoors. And that's not to say you have to like going outdoors to be a geoscientist at all, because there's lots of things to do in terms of geological research or geoscience research which are indoors. But for me, that was a strong draw. It also helped that I wasn't very good at lots of other things. So science was my worst GCSE grade. There you go. So I got it was my lowest GCSE grade, and that's because for me, things like physics, chemistry, biology, I'm not the smartest of people, and I found those things a little bit abstract, like when they were kind of taught sometimes in a slightly classic abstract way. But geoscience for me, when I started to see kind of how physics related to the erosion of rocks and the transport of rocks, or the behavior of rivers, or I saw how biology was important in terms of taphonomy and paleontology and life on Earth. Things started to make a bit more sense for me in that way. So geoscience is ace in that way because it's a real kind of melting pot, a real assemblage of all of those different scientific disciplines, maths as well. So if you're interested in those STEM disciplines and you want to do something which allows you to look at the Earth around you and beneath your feet, but also with purpose, there's a real need for geoscientists now as we look towards, having a more sustainable future in terms of the types of resources we're using. When we think about the waste products we're generating, how we're going to try and get rid of those, there's lots of roles for geoscientists in there. So it's not just oil and gas. There's oil and gas is like a vanishingly small percentage of people who go into that. So, I think finding something you're really passionate about and something that, just is brought to life for you when somebody stands up and talks about it. That's kind of what worked for me. And I really think it's something that, the students who are on this who are listening in really should look for. And I hope it's geoscientists they go for, because I think it's just a fantastic thing. You get to look at super tiny things under a microscope. You get to look at massive plate boundaries. You get to go to volcanoes. You get to work with these super high-tech machines where you crush rocks, and there's just so many things to do in it that are lots of fun.
And I think hearing people like yourself also who have travelled around the world, who have investigating it, is really inspirational as well to a lot of students. I'm just going to end with one kind of question just from Richard, and then we've actually kind of answered all our questions, saying, so from Peter, saying, what single piece of knowledge do you think has the greatest impact in helping us manage volcanic hazards?
Oh, my word. I don't know. I mean, like the feeling I came away with when I've been to volcanic observatories and I kind of worked on Expedition Volcano was there is no one piece of knowledge. And I think the show touched on that. And I think if you read scientific pieces about volcanic monitoring, the key thing is the integrated approach. So it's not simply, if we understand that there's carbon dioxide and sulfur dioxide coming out of volcanoes and they might change, that's enough. We need that. But then we need geophysicists to look at, say, the seismicity, so the earthquakes, so maybe there's a change in the number and frequency and depth of earthquakes that are coupled with the change in the gases. And then there's a third bit, isn't there, which is, some volcanoes actively deform before they erupt sometimes, So as magma's moving into the volcanic edifice, you get the deformation of the volcano. So that's something we call geodesy. So that's a geophysical, you've got radars looking down at Earth. So that's the third bit. So you kind of take all of those different techniques, and I think it's only by bringing those techniques together do we really get something towards a body of knowledge around volcanic behavior. I just think, the classic, these people who have dogs, right, who say, I've got this volcanic eruption monitoring dog, and when the dog barks or runs around in circles chasing its tail, the volcano is going to erupt next Tuesday. I kind of suspect that's not true. Not least because there's no science in it, but also because maybe you need more than one dog running around in circles. Just integrate dogs.
That was a fantastic answer, and as I said, thank you so much. Before we leave, and thank you, as I said, it's so inspirational for so many students. So if you are thinking about geosciences for university, then hopefully you've been convinced. Do you have anything to plug? And I also have another question saying, how do you get one of those awesome t-shirts that you are wearing?
This one? Okay. Have I got anything to plug? No, not really. Watch the Christmas lectures, from Boxing Day, 2 days after that. It's going to be super good fun. I'm not writing any books. I'm not going on tour or anything like that. So I've got nothing to plug. But these Black and Geoscience t-shirts, you can buy them off teespring.com. Lucia Perez-Diaz is a friend of mine. She designed these in the wake of kind of all of the fun we had earlier this year to support Black people in general, but also to try and inspire Black geoscientists as well. So I strongly encourage you to go there. There's stickers, there's t-shirts, there's mugs, and she's raising money as well for very good causes. So yeah, please consider going to teespring.com.
Brilliant. Thank you so much for that. Well, thank you so much for taking the time to speak to us today, and I'll let you get on to enjoy the rest of the evening with your family.
No problem. They've all gone now, but they were kind of buzzing around the small one, but it's disappeared now. So yeah.
Thank you very much, and hopefully we've got a lot of people tuning in for that Christmas lecture as well.
Yeah, no problem.
Brilliant.
Okay, thank you.
Thank you. Right, for those who is half term next week, so there won't be anything on next week, but afterwards we are going to be speaking to David Holmes, who will be talking about kind of A levels, NEAs, etc. like that. So join us then the week after. I think it's on November 3rd, maybe, I can't see it, but yeah, apart from that, have a lovely rest of your evening. Thank you so much, and bye from me.